Hi, in this lesson, we understand how to use regular expressions in Oracle. Starting from Oracle 10G, we got support for regular expressions. We have four different functions dealing with regular expressions, and one more was added subsequently, which is regular expression count. Regular expression like is an enhanced version of our like operator. That means it supports regular expression and then regular expression in string, substring, and replace are similar to the string functions we have seen before, but these functions support regular expressions. But what is a regular expression? Regular expression is a string that can have meta characters. And these meta characters specify what are we exactly looking for. And if you see a few examples here, the first one says we are looking for any character in the given list. The list is consisting of A, B, C. So any character in that list will be a match to it. The next example shows not ABC. This is where I'm saying I'm looking for anything other than ABC because the caret symbol in square brackets is treated as not. This is where we talk about a range of characters, and this is where we say the string should start with what is given after that. So in this case, the string should start with a digit. And here the string should contain 10 digits. So this is where we are saying it should start with that, it should end with that, and in between we need to have 10 digits. We can also specify minimum and maximum occurrences. So 2 comma 4 means minimum 2, maximum 4. And another powerful concept is grouping. We are grouping our expressions. This is group 1, this is group 2. We'll see some examples using regular expression related functions. The first function is regular expression like. If the string is matching the pattern, it returns true. We can also give match options. For example, if you give I, it means you want to ignore the case while you are comparing strings. Let us see the first example. This is saying we are looking for employees where the first name is starting with STE, ending with EN, but in between we can have either V or PH. So the pipe symbol says either this or that. So Stephen or Steven will be a match to this. This is how we form the regular expression, and you are using regular expression like to check whether first name is a match to it. The second one is looking for street address where we have a digit at the beginning. So if the street address starts with a digit, it is a match. Let's go try them. So this is my first example. When I run this, it is giving me all the names where we have STE in the beginning, EN at the end. In between, you may have V or PH. The second example is looking for 3 digits at the beginning. I just improvised it and I'm saying I'm looking for not 1 but 3 digits. There you are. You get all the street addresses where we have at least 3 digits. Well, I can increase it to 5 or whatever I want. So if I say 5, I will get less number of matches. In fact, I'm getting only 1. Well, that's about it. The next regular expression function is instring. Unlike like, it is not returning boolean, it is returning the position of the match. So this is where I'm looking for the first alphabet in the street address. And this is one way to say we are looking for an alphabet. You can replace this with something like small a to small z, capital A to capital Z if you like. Or you can give alpha in this way. So we are looking for the first alphabet position in string returns the position. The second example is looking for at least 2 digits. So wherever we have 2 digits, it's going to return the position of that particular location. These are examples for regular expression in string. And substring is extracting whatever is matching the regular expression. So here we are looking for in the street address one or more digits. So wherever in the street address you find one or more digits, you extract that. But this is slightly more complex. We are looking for a space followed by one or more, because this plus means one or more. But what we are not looking for is digit and space. So start with a space, take all the characters other than digits and spaces, and that will be the match. So we are using not 0 to 9 and space. Let's check how it works. So this is my first example where I'm looking for regular expression in string, and I'm using this to find out the position of first alphabet. And when you run, you get something like this. So in this, the first alphabet is V, that is in 6th position. And similarly, regular expression substring, and here let's take this first. I'm looking for all the digits. So whatever digits we have, we get that. Of course, if you have multiple numbers, it will give you only the first number. It's not going to take the remaining. And the next one is regular expression replace. This can be used to replace a string with another string, but the first one is a regular expression. So wherever you have a dot, I want that to be replaced with hyphen. But this backslash before dot is needed because dot is itself a meta character. But in this case, I want to treat dot as a literal, not as a special character. And I'm using plus just to indicate in case you have more than one dot, even all those dots are to be replaced with a hyphen. So if you go and run this, we replace all the occurrences of dots in the string with hyphen. And this is another example just to demonstrate how we can replace one or more digits with 9. So wherever you have a digit, replace that with 9. So 5, 1, 5, all of them are replaced with 9. And this is pretty powerful. We are using grouping concept. So let's understand this. I'm using 2 groups here. The first group is looking for one or more digits at the beginning of the string. Then it is looking for a dot. Then it is looking for 0 or more characters. And this dot is treated as a literal dot, but this dot is treated as a special character. It means it's a match to any character. And I'm looking for 2 sets. The first set is one or more digits. The second set is any set of characters. And this is represented as a \1 first group. This is represented as \2. Now I'm saying replace the original string with the new string, where you put the first group first, followed by hyphen, followed by second group in parenthesis. Well, let's run this to see how exactly it works. Now there is our first number, and it is picking up these 3 digits. That becomes the first group. Then it is putting hyphen. And anything after this dot, the rest of that is going to be second group, and that is placed in parenthesis. This is our second group. So we can use grouping concept and select multiple values using multiple patterns like this. And this is a very useful function. It's like replace, but it supports regular expression so that we can precisely select what we want. The last function is regular expression count, which is just counting how many times the given pattern is found. And this is going to tell you how many times you have four or more alphabets in the street address. So in this case, it is finding three occurrences of string with four or more characters. Whereas in this, we found only one. Caller is the only match to it. So those are the options. Regular expression substring to extract a string. Regular expression replace is replacing one string with another. Count is counting. So in this lesson, we understood what is regular expression and how to use those 5 functions related to regular expressions. That's it for now. I'll catch you in the next lesson.